Hello students, let us solve one problem based on the concept
Circle.
from class 10th maths part 2. So this is the diagram given, and based on that the question is, in figure segment AB is the diameter of a circle with center C. Line PQ is a tangent which touches the circle at point T, and here it is given that AP is perpendicular to line PQ. PQ is perpendicular to line PQ, and from this one we have to prove that segment CP is congruent to segment CQ. So as we can see in the diagram, we have to show that segment CP is congruent to segment CQ. So for that we have to do one construction. We have to draw segment CP, segment CT, and segment CQ. So here we have to show that these two line segments CP and CQ are congruent. Now here we have also drawn one segment CT. CT is the radius of the circle, and line PQ is a tangent which touches the circle at point T. So from this one we can have segment CT is perpendicular to line PQ, because we know that the tangent is perpendicular to the radius. So this is the construction we have done. We have drawn segment CP, segment CQ, and segment CT. And we have segment CT is perpendicular to line PQ as tangent is perpendicular to the radius. It is given that segment AP is perpendicular to line PQ, and segment BQ is also perpendicular to line PQ. And by doing one construction, we have drawn segment CT, and as CT is a radius and PQ is a tangent, CT is perpendicular to line PQ. So from these three statements, as we can see, segment AP, segment CT, and segment BQ are perpendicular to the same line, that is line PQ. And if it is the condition, then from this we can conclude that all these three segments are parallel. That is, segment AP is parallel to segment CT, is parallel to segment. So these three segments are parallel to each other. And if we consider AB and PQ, they're transversal. So we have the property of three parallel lines and they're transversal. So first of all, let us understand what is this property. It is the property of three parallel lines and they're transversal. For that, let us consider this diagram. As you can see here, line AX, line BY, and line CZ are parallel to each other, and line L and line M intersects these three parallel lines at three different points. Line L intersects these three parallel lines at points A, B, and C, and line M intersects these three parallel lines at points X, Y, and Z. So if this is the case, that is, if there are three lines parallel to each other, and if there are two transversal given, then we have the line segment AB, BC, line segment XY, and YZ. So we have the relation between them as, if we take the ratio of AB and BC, that is AB divided by BC, it must be equal to the ratio of XY and YZ. So we can have AB divided by BC is equal to XY divided by YZ. So this is the property of three parallel lines and their transversal. So we have to use this property to solve the problem. So we can use this property in this diagram to solve the given problem. That is, if AP, CT, and BQ are three parallel segments, and if we consider AB and PQ as their transversals, then we have got segment AC and segment BC. So if we take the ratio, that is AC divided by BC, that must be equal to the two line segments which are formed on the another transversal, that is transversal PQ. Line segments are PT and TQ. So we should have here on the right hand side PT divided by TQ. That is, by this property we can write AC divided by BC is equal to PT divided by. Now consider AC divided by BC. So this ratio is 1 divided by 1 because AC and BC are the radii of the same circle, and we know that radii of the same circle are congruent. That's why AC is congruent to BC, that means the ratio is 1:1, that is 1 divided by 1. If the first ratio AC divided by BC is 1/1, then we must have the second ratio PT divided by TQ is also 1/1. Now if we cross multiply, we get PT into 1, that's PT, is equal to TQ into 1, that's TQ. So here we have proved here that segment PT is congruent to segment TQ. Here, due to the construction, segment CT is perpendicular to line PQ, and for segment PQ, PT is congruent to segment TQ, as we have proved here. So from these two, we can conclude that segment CT is the perpendicular bisector of segment PQ, because segment CT is perpendicular to segment PQ and PT is congruent to TQ. That means segment CT must be a perpendicular bisector of segment PQ. And we know the property of perpendicular bisector, that every point on the perpendicular bisector of a segment is equidistant from two end points of the segment. So point P and point Q are the two end points of segment PQ. So every point on this perpendicular line, that is perpendicular bisector CT, must be equidistant from points P and Q, and point C is on the perpendicular bisector, that means point C is also equidistant from points P and point Q. That's why we have point C is equidistant from points P and Q, that is CP is equal to CQ. And that is we wanted to prove. We have to prove that segment CP is congruent to segment CQ.